Hello guys, myself Nishant. So today I'll be explaining topic on predictive parsing. So without wasting any time, let's start. And the first one we have the LL1 grammar. Predictive parsers. Basically, this can be constructed for a class of grammars called LL1. L left, then comes the L leftmost derivation, then comes the one input symbol at each step. Then at the last we have the no left recursive or ambiguous grammar can be LL1. So what are the condition for the LL1? Grammar G is called LL1 if and only if wherever if A tends to alpha beta, then these are the two distinct production of G. The following condition holds: first alpha, first beta must be disjoint. This is to be able to deterministically guess the production. At most one of the strings alpha or beta can derive gamma. Since first alpha, first beta are disjoint, then we have if alpha tends to gamma, then first beta and follow A must be disjoint. Here we have the algorithm for construction of parsing table. So the input will be giving us grammar G, output is the parsing table EM. For each production A tends to alpha, we have to do the following steps. For each terminal A in first A, add A tends to alpha to M A comma alpha. If epsilon is in first alpha, then for each terminal B in follow A tends to alpha to M A comma B. If B is dollar, then also add A tends to alpha to M of A comma dollar. If there is no production in M of A comma A, then we'll be setting M of A comma A to error. So in the next slide we have the example. Example of LL1 grammar is that here E tends to T E dash, then E tends to T E dash slash epsilon, then T tends to F T dash, then T dash to multiply star of F T dash epsilon. Then at the end we have the F tends to E EID. So now we have the generated parser table for string id plus id star id. So in the non-terminal we'll be having e dash t t dash f. Then the input symbol will be given as star t dash tends to star f of t dash. Then for e here we'll be having as e tends to t e dash. Then we will be having the e dash. For e dash will be given as e tends to plus t e dash. Then we have the e dash tends to epsilon. Then again e dash tends to epsilon here. So then we have the t tends to ft dash. Then again t tends to ft dash. Then comes the t dash, and t dash tends to epsilon. T dash tends to star ft dash. Then we have the t dash as tending to epsilon. Then we have t dash tends to epsilon. At the end we have the f. F will be tending to id and f tends to e. Then we have the table driven predictive parsing. Predictive parsing can be built by maintaining a stack explicitly. The table driven parser has an input buffer stack containing sequence of grammar, symbol, parsing table, and an output stream. The input buffer contains the string to be parsed followed by dollar. Initially, the stacks contain the start symbol of the grammar on the top followed by dollar. The parsing table deterministically guess the correct production to be used. Here we have the flowchart in which first we have the table, then comes the parser, then the parser can move towards the stack and the input buffer. So then we have the procedure of predictive parser. So the steps are as the current symbol of the input string is maintained by a pointer, say IP. In every step, consider the set of a comma alpha, where a is the symbol pointed by the IP and alpha is the top of the stack. If alpha is a non-terminal, then we'll see the table cell m of alpha comma a for the production. If m of alpha comma a is a valid production, then we will pop up the stack. Then we will push the production into the stack. Then we have the next step as if m is alpha comma a is error or blank, then report an error. Then we'll be reporting an error. If alpha isn't terminal, then we'll pop it from the stack, and also we'll increment the input pointer IP to point the next symbol in the input string. The output will be the set of production. The following example illustrates the top-down predictive parser using parser table. So the string is as given as id plus id star id. The grammar will be mentioned ll1 grammar in the previous slide. So that's it. Thank you guys.